Okay, everyone, thanks again. And now we're going to get started. We have Courtney Crone, who is a Formula One race car driver, which is pretty cool. I know you look at her, you're like, really? And I've met quite a few women race car drivers over the years, both in Top Fuel and now Formula, and they all look like her. Like you would never know they race cars. So, Courtney, welcome. Can you just please tell us a bit about yourself and your racing background?
Yeah, so hi, I'm Courtney Crone. I'm 18 years old, and I've been racing for the last 14 years of my life. So I actually started at 4. I've driven everything from go-karts to actually motorcycles, speedway motorcycles, and I originally started out on dirt, so I ran midgets and sprint cars on a dirt oval racing, and in these last few years I've moved up to formula cars. So this year, I'm racing in the SCCA, which is a sanctioning body, in the Formula F class. So I'm running a Formula car. It's has no wings, slick tires, open cockpit, open wheel. So yeah, that's why I'm racing this year. Last year, I raced a car called a Formula Speed, which had wings, bigger tires, so they're about 200 horsepower, and we won 2 championships in that last year, so we kind of moved up a bit this year, and then hopefully in these next few years we can move up to, up the ranks to like Formula 4 and Indy cars, and so IndyCar would be the big goal.
Nice. And for Jimmy, this is Jimmy Buffy, or James Jimmy Buffy as he goes. He's with the LA Dodgers. He's an analyst. Tell us a bit about what you do for the Dodgers and why you do what you do for the Dodgers.
Yeah, sure. Yeah, my name is Jimmy. I have a background. My undergraduate degree was mechanical engineering, and then I actually got a PhD in biomechanics. Crazy thing, I actually started my PhD studying prosthetic hands, but I love baseball, I love sports, and then a few years into my PhD studying prosthetic hands, I came across research on elbow injuries because I was studying hand muscles. So like hand muscles, elbow injuries, pitching, oh, there's a connection here. So then I changed my PhD project from studying prosthetic hands to doing computer simulations using motion data to study baseball pitching injuries. So it's kind of like a crazy leap that I took. My advisor was like, I don't know if you're going to get a job in that, but you could do it. It sounds cool. But yeah, so then like through a bunch of random set of circumstances, the Dodgers hired me, and it was sort of the same kind of thing. When they hired me, they're like, we don't really know what you're going to do for us because we don't really have the tech to do what you need to do, but you can give it a shot. We'll give you some money, give it a shot. So it was very cool. When I first started at the Dodgers, they didn't even have slow motion cameras. So they were like, Jimmy, we know you use motion data to help pitchers move better. So like figure out how to do that for the Dodgers. So it was cool. I had the opportunity to buy a bunch of technology, see the space, the IoT space, all IMUs, computer vision. We purchased a bunch of stuff, got a bunch of data, and now my job is we record the movements of Dodger pitchers and hitters, and my job is to use that movement data to help the pitchers and hitters move better. And it's super fun. It's like a combination of sitting in front of a computer, analyzing data, but then also interfacing with the coaches and the players and be like, this is the data that we have, and this is how we think it could help you. And a big, big part of that has been the collaboration with the coaches and the athletes because, using movement data is so hard and so complex that like you got to use coaching intuition to build up the algorithms. It's a very like collaborative process. But yeah, so I guess it's sort of a long story, but my job is using movement data to help Dodger players move better.
Very cool. Leaping off of the technology, Courtney, what differences in technology do you see between formula racing and the other types of racing?
So that would relate a lot to when I race midgets and sprint cars versus now these formula cars. Midgets and sprint cars use, honestly, the cars haven't changed much since they put roll cages on them in the 60s. Not a lot of technology goes into that, and there's definitely not a lot of feedback for drivers to go off of. In the car that I race now, we have AIM systems, which AIM is a data system that they have in these cars that once you get off the track, you can download the data that's in these cars onto a laptop, and you can see the sensor. We have sensors on throttle bodies, on brakes, on gear sensors to see what gear you're in and what corner. There's gear sensors on your mile an hour, steering sensors. So you can see the difference of like, it's more of a driver feedback type of a thing. And so you can see like, well, you're on throttle and your speed is actually going down. So why is that happening? Maybe it's because you have 80% steering input in your car and you're like, wow, okay, so you're actually decreasing your speed. So it's more of a reference to help your driving, kind of like with the pitching. They're looking at data and analyzing to make them pitch better. It's making us drive better. And then there's also data for the engineers to look over, as for like oil temperatures and just a lot of other stuff that really goes into the engines of these cars that the engineers use to set up the cars and based on driver feedback and the data. And the difference between using that and going to the midgets and sprint cars where there's no data in that sense, it is a lot harder for engineers to set up the cars because there's a lot more based on the driver's input. And if you have a driver that's not very good at feedback, they could be a great driver, but just not good at feedback. There's no way for the engineers to set up the car because they just they don't have that feedback that is great from the driver. So back 30, 40 years ago when there was not as much data on formula cars and stuff, that's why they always say it makes the great drivers really great, because they have that sense of feeling in the cars and being able to give that sort of feedback. So now they say nowadays racing is a lot easier because now you can blame stuff on the drivers, and the drivers can't make up stories of why this or that happened because they have the data to tell the truth about what really did happen. So the difference from now to 30, 40 years ago, or even cars nowadays that don't have that data system and video even that we put on the cars is pretty substantial, and it's really helped develop drivers and cars in the last 10 years, 20 years.
It's amazing. I'm still trying to picture you in that 200 mile an hour car. Now for Jimmy, what do you look for in technology specifically for pitching in baseball? I know there's a lot of other positions, but for pitching.
So, some of the most important things, especially for pitching is, there's I guess two things are like simplicity and comfort. Maybe three things, and responsiveness. So we use a lot of different like wearable technologies. We've tried a lot of different wearable technologies. We've used a lot of like computer vision based systems to track how the ball moves. But we get so much pushback if the numbers don't populate right away. Like you can imagine a pitcher throwing a bullpen, right? He throws a pitch and then 10 seconds later he throws another pitch. If he's like sitting there like 15 seconds, no number, then he's like, that's all right. It doesn't matter anyway. And then he just moves on. So responsiveness is super important, something that we look for a lot with pitching. Simplicity too. When you look at the movement of a baseball in space, you can describe that with an infinite amount of numbers, really. But we see the best thing is the pitchers always want, like 1, 2, or 3 numbers that help me get better, right? Like a lot of times you see these reports and they have graphs and charts and numbers, and the player's like, I don't have time. That's not my area of expertise. I play, right? So give me a couple things that help me play better. So it's like responsiveness, simplicity, and then comfort too is a really big one. Like when we've tried a bunch of wearable sensors, like pitchers are creatures of habit. Like it's such a fine precision. Like I think you have like 1 or 2 degrees margin of error if you want to throw a strike with your fingers, right? So you can imagine if you have a sensor on your hand and that throws off your feel by 3 degrees, well then you can't throw a strike. So those are I think the 3 things that we really look for with technology: responsiveness, simplicity, and comfort.
And just to follow up, have you had to create anything on the fly when you've had let's say you've taken an existing sensor Have you had to modify thinking, okay, this could work, let me modify this now and see if it's going to work?
Well, I don't know exactly like on the fly,
Yeah.
but like there are a lot of systems that we use where we've had to modify them for sure, or not modify, but just like massage the data to make it actionable, right? Like the biggest one that comes to mind immediately is movement data. That's what I've studied, and a lot of times there are companies that want to give you like movement data. But like what they do is they just, like I said, they dump a pile of graphs and numbers on your desk, and then they like use your analysts or like you see this peak right here and then this trough right here. Like this means this, this, and this, and you need a PhD to figure it out. So like modifying, like one of the biggest things that we've had to do with the movement data is really simplify it. Like you have 10 graphs of how your torso is moving in space, but then we want to simplify it basically to, I guess get a little bit like in the weeds baseball, but a lot of times we consider there's a spectrum of pitching from like guys who throw north-south over the top to guys that throw east-west or side to side, and you can be like anywhere along that spectrum. And that's something that we've done is like you have all of these movement data, but then now we've started to simplify it to like one number is like, okay, you are a 90-degree pitcher, which is you're perfectly over the top. Or you are a 45-degree pitcher. So that means you're perfectly in the middle, and then that informs a lot of training and a lot of coaching. So that's how, a way that we modify data to make it simpler and more actionable for pitchers.
So, and to follow, kind of same to you, Courtney, you spoke about all the data, all the sensors that are already in cars to pretty much tell the driver, hey, you're screwing up or not. Have you had to modify certain things for yourself, or have other drivers had to modify the technology for themselves?
Yeah, so the data is more like off track. Like once you're already finished, like you don't get that while you're on track. But what you can do on track is we do have these little screens, on the steering wheels. A big thing that a lot of drivers like to use is predictive lap timing, which is it's pretty new in the last 10 years or so. If you look at Formula One cars and stuff in the 90s, they didn't really have screens yet. There's just oil pressure and whatever gauges. Now it's these digital screens that, on Indy cars, now there's, even a little panel right there that shows when your tires heat up. It'll tell you, okay, your tires are good to go. And so predictive lap timing is something that I use as a crucial point, as if I know a track well enough, I can tell if I'm a tenth or above or below where I am in turn 2 on a lap that I think is going to be great. It'll tell you that, and you can use that to just kind of judge how you're driving, and if you know that is going to be a good lap or if it's a throwaway. So using these predictive lap times on these screens that they have is a huge, crucial part of drivers, and just some in-car stuff that they can use, because it is limited inside a cockpit, to have many things, and there is mechanical adjustments as like sway bar adjusters and stuff like that. But definitely when you move up the ranks and you get into cars like Indy cars, Formula One cars, there's a lot more different things you can use on these wheels and stuff, that they can do the different engine mappings and stuff like that. As to where the type of car that I'm running right now, it's a little more limited, but we do have our own certain little options that we can use in car.
Cool. Well, thank you for that. Now, this is going to be pretty much the same question for both of you, so you can go or you can hold on to the mic. It is sports tech. We do have some entrepreneurs here inside the venue. Are there many entrepreneurs in your field of racing that are looking to develop something that's going to make you a better driver or make the car faster?
Yeah, for like when you're going to start talking about Formula One cars, I mean, they have McLaren and Honda for Indy cars, and Chevy, they're always developing new technology. new aero kits for these cars that'll affect the aerodynamics, but yet not compromise the racing. Because to a point where if you make a car too fast, the racing is just not going to be as good because it's going to kind of take away the competition of these drivers passing and all that, and then it's going to higher the risk of crashes and how badly injured these drivers can get. So there's new technology happening every day to help these open wheel, open cockpit cars also in safety. IndyCar has released their new 2021 body that they're going to put out, and there's actually it's a windscreen that goes over the front of the cars to keep debris and different things from entering the cockpit, because a few years ago Justin Wilson was hit by a spring that came off a car in front of him and killed him. So with this new technology, with this windscreen, it's going to keep from objects, or when you crash, a car splitting in half and you hitting the wall or ground, whatever. So a lot of technology has been involved in not only developing the cars and speed and body and aero and stuff, but also safety.
Thank you. And for Jamie, I just want to modify your question a little bit, but what advice would you give entrepreneurs trying to develop technology for, in this case, let's say baseball or pitchers?
Yeah, I mean, I guess it goes back to what you're saying. What do we look for is like simplicity, actionable, responsiveness. Those are all like super important. Like I've never seen people lose buy-in faster than when a device is like the Bluetooth connectivity drops, and then the pitcher's trying to like do his thing, but then he's waiting for numbers and it's not happening, and he's like, okay, that's it. So like responsiveness is super important. Even if the number's not perfect, like you got to show somebody something in a reasonable period of time. And then like advice probably too is like you got to spend time with the athletes and the coaches and make it collaborative so that it can be actionable, simple, like learn the language that the players and the coaches use, so that way your technology can communicate using that language. Like I guess when you were talking about modifying things, like a big thing, I guess I'll give another specific example. We use technology that tracks how balls move through space, right? And a big thing, if you follow baseball, rise, vertical break, that's a big thing that people talk about. And then, we get this technology, and it pops out numbers that are trying to describe this. And the words that they use to describe this upward movement of the baseball are induced vertical break. Come on, guys, could you have come up with anything that's more obscure? Like, let's use the language. Like when coaches talk about it, they talk about life, they talk about rise, and the company drops something on our desk that's like induced vertical break, and the coach is like, "What is induced vertical break?" And we have to be like, it's just rise. It's like, so like spending time with the coaches and the athletes, collaborating with them is like the biggest advice that I can give to anybody like building a sports technology device.
Great. Well, thank you both for participating in our panel, and continued luck with, obviously, the Dodgers,
Yeah.
continued luck with the racing, and hopefully everything continues there forth.